All right. So welcome to Dr. Carter's again. So we have mathematics today. We'll continue with the chapters that we left off the last discussion. Right. So today we'll look at arithmetic progression, geometric progression. Of course, we look at the series or summation. Right. Now, let's just briefly look at these numbers. Let's say I have these numbers 1, 3, 3, 5, 7, 9. You realize that from 1 to 3, we added 2. From 3 to 5, we added 2. From 5 to 7, we added 2. From 7 to 9, we added 2. So a number in which from one number to the other comes in the form of addition with the same number. Or if you are looking at it from the backwards direction, it has to be subtracted. The same constant. That becomes what we call the arithmetic progression. Right, so if you look at this, you can easily deduce a formula for it, okay? Usually we say this is T subscript n, or the 10 referring to any of the numbers or elements, okay? Right, S would be the summation, the sum up to. Usually we are looking at the cumulative, okay? Cumulative sum up to a certain element. Alright, so if we have all these at the back of our mind and looking at this, assuming if this is we let this term be, let's say, A. See that the first term is A, the second term will be A plus the difference that you are adding. The next term will be what? A, so it will be this one that you have here plus the difference again. Let's see what happens. The next one, it will be this that you have here plus D again. So if you look at this, you are going to have A plus D. This is going to give us what? A plus D, 2D. This is going to give us what? A plus 3D. Right, now this is the first term. This is Tn. This is, sorry, T1, T2, T3, T4. Now if you look at it critically, especially from this point, where you have T2, so that this is to the power 1. Where you have T3, this is 1. Where you have T3 is what? 2. Where you have T4, this becomes what? 3. So, but A is always constant there. So from this, you can deduce that T will be equal to this one, which appears in all the equations, plus if the term is n, then it is going to be n minus 1, because as it happens here, this is 3, it becomes 2, this is 4, it becomes 3. And then the difference comes, okay? So this is a simple way to get the formula for the arithmetic progression, or the sequence. Right, so this will be a general formula. Good. Now, let's look at for a certain progression or a certain number. Let's say, let me just fill in this one. So that's the formula. We can keep this formula. Now let's look at the geometric progression. Now I have this number 2. I multiply by 2, 4, 4 by 2, I get 8, 8 by 2, that's 16, 32, and so on and so forth. Now, if you look at these numbers, there's a pattern that you can recognize. You realize that these 2 to this 4 would have said maybe we added 2. Let's see whether it works. Now, if we added 2 from 4 to 8, adding 2 will not give you 8, it will rather give you 6. So you realize that this is not a linear, the first equation that we describe, arithmetic progression. You realize that this doesn't follow. Now try the other way, or try the other method and see. Now if you multiply this by 2, you will get 4. Now if you multiply the answer that you have, this 4 by 2, you get 8. Multiply 8 by 2, you get 16. So you realize that this comes in the form of multiplication. Now as you move forward, it's multiplication. Of course, then when you are coming back, it will be division. So this kind of sequence or order of numbers that comes with a certain factor being multiplying the numbers, a certain factor multiplying the numbers, then we call this kind of equation geometric progression. Okay, so you realize that if you want to find the answer, let's see, this is T1 and T2, T3, and so on. Now let's see. Realize the first number, you have 2 as it is. Now the second number, to get the second number, you have to multiply, assuming this is the factor that we are using to multiply. 2 is a factor. Realize that we have to multiply the answer, the first number 2, by our factor r. Okay, but what factor to what power? Now, as we go on, let's see how it happens. The next one, we have to multiply this one by 2. The next one, we have to multiply what our second number, which is 4, by r. Now, if you do this over and then you look at the pattern properly, you will realize that these are the numbers that we have, okay, and we are multiplying by that, okay. It's the same as having, at this point, it's the same as having this times r, okay. So you see that T3 is becoming something like this, 2r to the power what? 2. Now this is the first constant. Now just look at this pattern here. If you look at it critically, now this is 3, and this is raised to the power 2. This is the constant, the first number that we started with. So if you want to write a general equation for this, it becomes very easy for you to predict the formula for this kind of progression called the geometric progression. From this, we can say that if Tn for any term n, then the first number that we are dealing with, let's assume that is a, should be multiplied by the factor, and of course raised to the exponent or the power that it will raise to will be short by 1, so it will be n minus 1, and this becomes the general equation for the geometric progression. So you see, it becomes very easy. If you look at the pattern, you pick an example, you should be able to derive the equation, and that is the formula for geometric progression, geometric sequence, right? Now, these are the terms, the numbers. Now let's look at when you are summing them, what happens. So you may not necessarily have to commit the formulas to memory. What you can do is, as you work with the formulas, they will stick anyway. But where you've forgotten, you can easily deduce these formulas. So let's look at the summation. Summation for Sn, summation for AP. Remember, we had the formula there already. What is the formula? A plus n minus 1 b. Now the formula for summation, let's say we have 1, 3, 5, 7, and so on. The summation, that's 1 plus 3 plus 1 plus 7, and so on. Let's say we are summing to this point. Okay, that becomes the summation. So usually is the summation up to a point. Starting from the first one up to a point. That's what this formula is going to give us. Okay, and then if we look at it we can have an example. You can have this expression, and then have this. If you add them, the equation will come out to you can assume this is one of the numbers. If you write them in that order, let's say a plus d and so on, and then you have the other one, you tell them around a minus 1, b, and then you keep adding them, so that you come out to the same formula, which will come out to give you an answer in this form. Right, so Sn comes out as n over 2 bracket 2a plus the same formula that we have, the n minus 1 d. Right, so this is the formula for summation for AP, or arithmetic progression, or the sequence where we are adding, Now if you look at this formula very well, you realize that this can be split into something like this: n over 2 a plus n minus 1 d, and so on. So this is what we have, and we can express just this one, split them into 2. What do you realize? You realize that this is equivalent to Tn is equal to that's the last term, so this becomes Tn, okay, and this is our first term, which is T1, right? Okay, so the formula can be rewritten as this: n over 2 times that. So this is also another formula. You can look at these two formulas for your summation. So when you're asked to find the summation after a certain term, you just need to know the first number, the term that you are looking at, and then the difference, okay, or the number that is being added or being subtracted to give you that sequence, and that will make the calculation go on well. So that is for AP summation or AP series, what you get, right? Now let's look at the geometric progression 1. Of course, in deriving it, I told you can just turn. If you turn, you see that a plus this is giving you 2a, then plus that, and then that is, it will be repeating itself, okay? So if you look at it very well, of course, the number of terms that you have, it will, all this will be repeating, and then it will be repeating by how many terms? The number of terms that you are having. This is what I mean. If you add this, you are going to get 2a plus n minus 1 d. You get this term n times, so it becomes n, and of course you have will also be half of that will be giving you the answer, and then that will be incorporated to give you the final equation as n over 2 into bracket 2a plus n minus 1 d as a formula for summation for AP sequence, or AP summation, AP series or summation, right? So that is that. Now, if you know the formulas, like I said, once you know the formula, it's about substitution. When a question is given to you, you only need to put in the figures. So that's what I mean. Maybe you were told the first term is 5, the last term, the seventh term is 8, or let's say it's 18. What's the sum? Okay, then know your sum. N over 2a plus n minus 1 d. Okay, then you are told the difference is, let's say, 2. So all you do is you put the first term here 2 times 1. How many terms? We are 7. Okay, plus n 7 minus 1. And then you're saying the difference there, it is 2. So it's just about substitution, and then you get your answer. That's exactly what we are talking about. Right. So if you're able to write the formula, you should be able to do the substitution from first principles. Right, so let's look at the geometric progression 1. If you have the first one, so the geometric series, we are now looking at it. Okay, that's the sum. Of course, we are saying the sum becomes series, right? So the series is the summation up to a point. Okay, then the sequence is the individual numbers that you are having. Right, so the summation, what will be, how do you go or come by the formula? Of course, we've already said Tn is equal to your A, R, negative 1. Okay, so you see that you have your first term, the next term will be times r, which is going to be 2 minus 1, so to that. The next term will be a r, which is going to be 2. Okay, a r is going to be 3. So if you turn it, then you're going to have your a and r1 here. Now, if you add in them, you do that, you add in them, then you're going to get 2Sn is equal to that. And of course, now if you subtract or you do your modifications and then calculations, then you will be able to derive the answer, derive an expression relating to that. But you see, when it comes to, this is going to be a complex way to come by the answer. So you are better off probably multiplying so Sn comes with its expression as given in the first instance. Let's assume we take this one. Right, so let me just be brief on this so that we get it. So let's assume, so we are on the metric series, okay? Right, so we have our summation, the sum, if you are adding the numbers, let's say s to the power n, become the first one, which we have, the second one will be that, plus the third one which will be r to the power 2, okay, plus ar to the power 3, and so on until we come to arn minus 1. Now, if we multiply through by r, let's say r times Sn, then you're going to get ar plus r squared plus r cubed, ar to the power 4, and then this is going to be s times r. So we're going to get r n minus 1 plus 1. So it's like this plus 1 is going to cancel that. And this is going to give us r Sn is equal to ar plus ar squared plus ar cubed plus ar to the power 4, and then ar to the power n. Now, if you look at this expression here and this expression here, you realize that if you subtract this one from that, this is corresponding to that, this is corresponding to that, this is corresponding to that, this, okay, of course, will correspond to a number k. Now, if you do that at the end, then this number is going to also subtract from 1, so it's just going to be, so this is going for the last term here. Of course, you have the preceding this one. If you are multiplying by that, that's what you have in here. So you have this number, and they are going to cancel. Right, so it will go in that sense. Right, so you realize that, like I said, this is going to take care of that and so. But before the number that precedes this one, of course, if we were multiplying, the number that would have been here would be arn minus 1 minus 2, because that will be the number preceding this one, okay? So if you multiply this one by another r, then it's going to be, the number just before this will be arn minus 1. So this will also take care of this. Now, so if we say Sn minus r Sn, then we are going to have these ones cancelling each other because we are subtracting this equation from that. Okay, and this will end up giving us this, and of course this will be left here. So we have a plus a to the power of n. Then this is the expression, and from this we should be able to rearrange to get our the formula. So of course this will come out as your formula here as Sn out, that will be 1 minus r, of course is equal to a out 1 minus r to the power n. Right. So this is, from here it becomes very simple to make this the subject, so that you divide here by your r 1 minus r, same thing 1 minus r. This will cancel that. And then you have Sn is equal to a 1 minus r to the power n over 1 minus r here. So this becomes summation or the series formula for geometric series, right? So there's the formula, but we should take note of something here. Now, you see that when you have an expression like this, it is always good to make notice for the denominator. Now, if here happens to be r happens to be equal to, let's say the ratio happens to be equal to 1, what do you think will happen to this equation? It is going to be 1 minus 1, which is going to be a 0. Of course, any number divided by 0 will be what's not defined. Okay, so we should quote that in this sense of the equation, r should not be equal to 1. Okay, if r is equal to 1, then you need to reverse the equation to give you a 1 minus, rn minus 1 over r minus 1, and this becomes the equation that you can use. This is not there, and that becomes the equation that you can use. Let me write it here so that you can see it. That is where r is equal to 1. This equation is what you use to get your summation. Right, so that ends the section for the series or the summation, the accumulated summation kind of equation. Now, I want to be so bare with you so that you understand most of these, how these formulas are derived. Once you know how to derive it, and of course you keep on working with examples, these will get naturally stuck in your brain, or you'll be able to imbibe that. Of course, where for a long time you've not been dealing with such equations, you can go by the first principles and then you'll still be able to arrive at the formulas. Alright, so let's move on to the next section. So, like I said, it is good to understand how most of these formulas are derived. If you know that, then it becomes very simple to do the substitution when the question is given to you. So we'll move on to the next one. So you can have an AP progression and then a GP progression. Then the question can be stated where the two are being used, okay? So you read the question and get it. If they are being added, add them, and then derive the necessary equation to solve them, okay? You can have GP and GP being added, you can have AP and GP being added, you can have what AP and AP being added. So it's just, you know the formulas. Tn is equal to your what? A plus n minus 1 d. You know its summation. Summation is equal to n over 2 to a plus n minus 1 d. Okay, so it's just manipulation depending on the question, how the question is stated, and then you'll be able to do that. So you can have the mixed series where we have the two being added, AP progression, GP progression, and then you are told that maybe the first three sequences are added or are subtracted, or the third sequence in this and then the fifth sequence in this are added, and the answer is this. So it's just a manipulation of the formulas and then going through first principles to get your answer. Alright, so we'll have a trial on most of these questions, but if you get a principle here, it's easy. So if I say the sequence is arithmetic progression and it is being added to a series, a geometric series, then of course we are talking about S is equal to your A into bracket 1 minus r n over 1 minus r. So this kind of, it depends. So depending on the question, then you write the appropriate equation and deal with it at that level. So just get the formulas well in your mind, and then read the question well, substitute, think about the question. If it is series, use series. If it is progression or sequence, use the sequence formula. If there is a mix, then you look at the two formulas being manipulated here and there. So if the series, you know, is summation. If the sequence, individual numbers, then that is the principle. Now so we have talked about the separate individuals, we have talked about the mix. Then we can have another kind of expression, or another kind of, let me put it in inverted commas, series or sequence, or some kind of a progression or relationship. Well, that would be the best way, relation, some kind of relation. Okay, so that maybe if it is 2, I'm going to the next one. To get my next number, I have to manipulate this one. To get my next number, that's A. Now to get my next number B, I have to manipulate this one. So this kind of relation will be recurrent or recurrent relation. Recurrent relation. Right? So where if I want to get, if it is Tn, and I'm going to the next one, Tn plus 1, I have to manipulate this one. If I'm going to Tn plus 2, I have to manipulate this equation. Right? So this kind of relation is what we call the recurrent relation. Now this relation, usually, if you are manipulating them, it is the term, etc., the terms that you actually do the manipulations for. This is what I mean. Let's say if you want to subtract, if there's a change in the relationship, the change affects these ones in their formula. Okay, so in their formulas, where they are is where you put them are. So let's say it's half Tn plus 2, then there's a change in Tn, then it becomes half into bracket, let's say Tn minus plus 3. So you don't add it to the whole equation. Okay, it will only affect this one which is changing. So it's some kind of a partial kind of relationship. So that is how you manipulate that. And then sometimes you want to change a relation, change the relation to geometric 1. If you subtract there's a Tn plus 1, you just subtract maybe a factor from this and do the same thing. Let's say Tn, the same factor from that, and then you convert it to you convert it to your geometric sequence. Okay, so that is our progression. That is how you can manipulate this recurrent relation. So the recurrent relation is usually the number preceding it is what determines the next number. So it means for us to know any term, which is any term with Tn plus 1. So this is the recurrent one, recurrent Tn plus 1. For us to know any Tn, we should know something about the number preceding, which is T. So Tn plus 1 means Tn is the number preceding it, plus 1 is the next one. So that the next number that we are interested in, which is the recurrent relation, should depend on this one by a certain expression. Okay, and that is, you don't have a general formula for it. It will come in various dynamics or various forms. Right, so that will be the next, the recurrent relation. Okay. So, in summary, let me just briefly go over so that we have a very good foundation when it comes to the geometric AP and GP and then their manipulations. Okay, right. So, all that we have said so far is that AP, you can have the sequence, you can have the summation or the series. Of course, the formula we know as what Tn is equal to our A plus n minus 1. And then our summation is going to, summation is equal to n over 2a, plus n minus 1 b. And then we said this can also be rewritten as this. T1, the first one, and then T final. Okay, this is a simple way to remember. Then we came to our GP and said the sequence or the progression is given by Tn is equal to first number, then the ratio, the number that we are, the factor that we are multiplying by, and is short of by 1, so n minus 1. The sum or the series or the summation comes out as Sn. We got what a to bracket 1 minus r to the power n or over 1 minus r. Of course, then we said if r, the ratio is 1, then we need to reverse the equation. So n becomes a rn minus 1 over r minus 1. Right. So this is for that and that. And then we said we can have the mixed kind of question where you can have GP being manipulated with AP. It can be class, any kind of manipulation. Right, that's a mix. Okay? Sometimes it can be AP and AP, or AP and AP. It can be GP and GP. Right, so then we came to the last one, recurrent relation. Okay, that one we said the next term we are looking, when it comes here we are looking at the next term. So the next number. So the next number, which is n plus 1, that's why we are adding plus 1. This is the number itself. The next number is n plus 1. N subscript n plus 1 will be dependent on the number before it, which is Tn. Okay, by certain manipulation. Okay, so that is that. So if you want to make any adjustment in this equation, you usually would manipulate the Tn plus Tn subscript n plus 1, and then the Tn. These are the ones that you manipulate. Okay, and then the equation will be modified by that manipulation. So this is exactly what we have done today. Have this at the back of your mind. You should be able to sail through with questions that. So the next will be to substitute. Okay, so once you're able to derive these ones from first principles, the substitution becomes very easy. So if a question is given to you, the first term, you put the first term there. The difference is given to you. The term that you have been asked to find, you find that term is n, and then you do your work out your equation. Then you get your answer. Sometimes it will be in the form of expression. Then you do the same thing, right? So that is that. If you remember, we have proportionality. Okay, kind of questions that usually may be part of this. So I will just briefly talk about that. I wanted to spend much time on this series because it's become very. So let's say T is proportional to. We can move this proportionality sign where T is equal to K constant, proportionality constant instead. That is how it goes. Now sometimes T can be partially, T may be partially dependent on let's say F and partially also on let's say K. So in that case we are having something like this, okay, and T, and that one will usually be added by either plus or minus because of the partial relationship with this and partial relationship with that. So that is how those kind of things will also be worked out. Now we move on. Let's look at the next chapter that we have to deal with. I think today we didn't waste much time.